My name is Brad Bradley. I'm very excited to share with you with the audience about ADA accessibility, and we're gonna refer to that, or I'm going to try to refer to that most often as safety and accessibility, because safety and accessibility go hand in hand, and our interest is in providing safety to all users, and accessibility is just a component of that. So I'm going to turn my camera off. We'll go from here. This is the ADA for design, construction, and maintenance. And I'm glad everyone's here. I'm excited to share with you how the FDOT addresses ADA safety and accessibility. Okay, first ahead, we're going to talk about just very quickly a brief background of the ADA law and when it was passed. Then we're going to go directly into the design requirements, and that's going to be the bulk of today's topic or discussion, because the design requirements translate into both the construction environment and then, of course, into the operations environment. So we'll spend a fair amount of time on design, and then we'll talk about construction access and how that works in Florida DOT projects. And then we'll move into the maintenance. That's operation and maintenance phase of the presentation. Okay, the law was signed into, or the law was signed into effect July 26, 1990 by the first George Bush, and it became effective roughly 18 months later in January of 1992. For the brief background of civil rights, the Civil Rights Act of 1964 established what's called protected classes for the categories of race, color, and national origin. Persons with disabilities were added to the civil rights coverage of United States law as a protected class back in 1990 when the law was signed. So persons with disabilities are now a protected class, the same as people with, it's just the same as the categories of race, color, and national origin. Now the ADA is divided up into 5 titles or sections. And the title that we're going to be discussing in today's webinar is Title II for Public Services. Now, why that's important is because pedestrian facilities provided by a government entity are considered to be public services. And the ADA requires that all services, programs, and activities remain accessible to and usable by persons with disabilities. So now we're going to address the design requirements of the FDOT. First of all, I want to mention that it's not rocket science. At the end of the day, you can boil down the primary elements that have to be considered for accessibility and safety down to the unobstructed clear width, which feeds directly into the next bullet for protruding objects. There we're dealing with signs and equipment and landscape material. And keep in mind that there are 2 different vertical clearance measurements for each of those sub-bullets there. Running slopes and cross slopes are an important factor for safety and accessibility. And then you have the walking surface itself, its condition, whether there are changes in level or not, and the existence of gaps and grates and other surface features within the walking surface of the pedestrian environment. It's important to note here that there are 2 specific governing documents that share this design criteria, if you will, for ADA safety and accessibility. The first one is the FDM for FDOT, and that applies to all state projects. The Florida Green Book applies to roadway projects that are provided by the locals, what we call the locals, cities and counties jurisdiction. All right, at this point, I want to borrow a concept from the Highway Safety Manual. Hopefully most people on the line here are familiar with the HSM, the Highway Safety Manual. But the HSM discusses the concept of nominal compliance versus substantive compliance. The idea of nominal compliance is basically adherence to the letter of the law, let's say. And substantive compliance is adherence to the spirit or the intent of the law. It's the operational and functioning of the, in the case of the HSM, we're dealing with roadway analysis and safety. When it comes to ADA safety and accessibility, nominal compliance would be the bare minimum that's expected on the state highway system or the local roadway network. It's considered the baseline. It meets expectations. It's the baseline. Substantive compliance, though, I think to me speaks to how is it functioning operationally? How are the users interacting with the pedestrian environment, and is it working? Is it safe and accessible for them? Nominal compliance, again, is the baseline, but substantive compliance requires engineers to exercise sound and effective engineering judgment to provide a solution that is more than just meets the level of expectation, but maybe we can tweak it a little bit and get to exceeds expectations, or we can even tweak it a little more and get to outstanding performance. That's kind of a concept that I'm going to try to weave into my discussion as we move forward. Now, FDM Chapter 222 is where the minimum criteria resides for the state highway system. Minimum criteria, that's meets performance expectations. But again, with a little bit of sound engineering judgment, some innovative thinking, and some consideration from the very beginning, engineers and designers can, with negligible, if any, impact to scope, schedule, and budget, can make sure that we're providing a full pedestrian facility network that is fully accessible to and usable by persons with disabilities, as well as being safe for all users. Now, note in the second paragraph here that it says pedestrians should be expected on all of Florida's state roadways. And I would add to that, and local roadway networks too. And I meant to mention on the previous slide, the backbone or the outline of this presentation is based on Chapter 222 of the FDM, but I have provided Florida Green Book references in green text with yellow highlight where they are appropriate. So the state requirements are going to be FDM, and the local roadway requirements are going to be the references to the Green Book. Now, pedestrians are defined as including persons traveling on foot and in a wheelchair. And where the requirements in the FDM or the Florida Green Book cannot be followed, then a design variation is required. That's covered in 122 of the FDM and Chapter 14 of the Green Book. And that's not just a pesky DOT requirement, but that in fact is required by federal regulation. And it's enforced by the US DOJ ultimately. And if you're interested in reading more about that in the regulations, then you can search for the word technical infeasibility. Okay, in this presentation, I'm going to hit the highlights of the criteria, but I'm not going to be able to go in depth in some of these topics. So I would always encourage the attendees to refer to the latest edition of both manuals online, and then also look at other relevant chapters that cover different factors or different aspects of the pedestrian environment. Now, the FDM defines a sidewalk as a continuous concrete pedestrian walkway as depicted in Standard Plans Index 522001. I want to focus just for a moment on the word continuous or continuity. This is expanding your thinking beyond just the linear connectivity of the sidewalk network, but I want you to also think about the consistent application of cross-sectional elements along that pedestrian facilities corridor. In other words, again, borrowing from the HSM, they have a concept of homogeneous segments. Well, we want the cross-sectional elements to be consistent or homogeneous as much as possible over the full length of the pedestrian facility corridor. That's going to add to or improve pedestrian safety and accessibility. The general notes make some references to some other standard plans in the 522 series. Note 2 is a reference to the detectable warning and curb ramp standard plans. That's 002. And then note 3 references 003, which is to driveways. And note 1 is a reference to the construction spec for sidewalks, and that's spec 522. Now, I wanted to mention, because this is a common misunderstanding of many folks, but sidewalks are not required by the ADA. But where they are required is according to DOT policy, which is not driven by ADA regulation and requirement, but it is actually just a function of DOT policy. So for more information on where sidewalks are expected to be per the FDOT, then I would encourage you to read further into Chapter 222, but we're not going to address that policy in today's webinar. The first real ADA element that we're going to talk about is the unobstructed clear width. And as you can see, hopefully on your screen, is a table 2.1, and this table applies to new construction and reconstruction. But I want to emphasize that the unobstructed clear width cannot include the top of the curb. The top of the curb is not part of the walking surface, so you cannot include that in your measurements for unobstructed clear width. Now, 5 feet in context classification C1 natural and C2 rural, 5 feet is going to be the narrowest sidewalk that the DOT generally is going to provide within a new construction or reconstruction project. Now, if existing sidewalks in 3R projects have not been included in the scope for improvement, then existing 4 feet or greater sidewalk widths can remain in any context classification. But ideally, for new construction and reconstruction, 5 feet is going to be the narrowest sidewalk provided by the DOT. Okay, real quickly, the vertical clearance requirement is 7 feet to fixed objects, and that's going to apply over the entire walking surface. So 7 feet is to fixed objects. And notice in the picture on the left is showing a sidewalk with some shrubbery, and the shrubbery is encroaching into the walking surface itself. Well, that's actually a violation, and it could be considered a barrier to accessibility for persons with disability. So it's a safety and accessibility issue, and it's something that needs to be addressed in maintenance. For running slope and cross slope, I want to distinguish now between the mainline sidewalk and then sidewalk connections from the mainline to off-site properties. The mainline sidewalk that is functioning to carry the pedestrian mode of travel adjacent to a roadway that is carrying obviously the vehicular mode of travel, that mainline sidewalk is permitted to mirror and follow the sidewalk grade. And you're not limited to the 5% max or 1 to 12 at the 8.33%. The distinguishing point I want to make here is that the mainline sidewalk, while it can follow the profile grade, the connections to the main line are from the main line to adjacent properties. Those sidewalk walking surfaces cannot take advantage of that provision of following the profile grade. In that case, I would direct your attention to the Florida Building Code, which provides information on how to address when your surface running slopes exceed 5% up to 8.3%. And that 8.3% is in fact a hard maximum. And if it cannot be achieved, then it would require a design variation. Continue on with grades and cross slopes. So the required cross slope, or the maximum allowable cross slope, I should say, is 2%. And that is a hard max at 2.0%. So where that comes into play is when sidewalk form boards are put down, and we're going to see that on the next slide. But before I go there, I wanted to mention that the size slopes adjacent to the sidewalk are limited within the first foot to a maximum of 1 to 6. And of course, drop-offs that exist within 2 feet of the edge of the sidewalk must be shielded per chapter or section 4 of this chapter. So the picture on the screen is showing form boards for the sidewalk before the concrete is poured, and this is the time in the building of the sidewalk when you want to verify your cross slopes. It's much easier to verify cross slopes with your form boards rather than waiting until the concrete hits the dirt. Standard Plans Index 522002, as I mentioned before, covers curb ramps and detectable warnings. These requirements, if they are met, will achieve nominal compliance that meets expectations. But we want our engineers to apply sound engineering judgment and make whatever tweaks they need to in order to remain compliant, nominally speaking, but to achieve a better and more functional solution, possibly with your substantive compliance. All right, real quick, general notes for Standard Plans Index 522002. I wanted to draw your attention to note 1A, and that to me is speaking to the difference between nominal compliance and substantive compliance. Nominal compliance, again, you're meeting the baseline, it's a meets expectations, but it's not going above and beyond. Where nominal compliance can't be met, then obviously we want to comply the closest solution to that nominal compliance as possible. But ideally, we want our engineers to think outside the box and go above and beyond. And if it means shifting the configuration of a ramp around a little bit, or doing some other modification to what would otherwise be a quote-unquote standard design, then we would encourage our designers to do that, because we want to provide a substantively safe and accessible pedestrian facility. Note 1B is talking about what I call level landings. And level is considered, if as far as the ADA is concerned, is a 0.02 slope in any direction. A surface slope of 0.02 in any direction is considered level as far as the ADA is concerned. Note 1C, where it says that a single longitudinal slope along each side of the curb ramp is required. To me, in my thinking, that's going to eliminate from compliance the use of a curved curb ramp. In other words, our curb ramps need to have a tangent alignment. And I would attribute that to note C there. The second part of note C talks about a 15-foot maximum length required to meet your running slope requirements of your curb ramp. That is to eliminate the need to follow the phenomenon of chasing grade. So curb ramp slope length only needs to be extended at maximum of 15 feet, and then you just tie into the roadway profile at the end of that 15 feet and provide a smooth transition at that point. Now, on your screen are two examples of curb ramp details from the standard plans. I wanted to point out that for the lower left, it shows an upper landing, if you will, at the top of the slope surface of 3 foot minimum. This detail should only be applied where the site footprint is restricted and a wider landing is not achievable. But what I would suggest to you is that a lot of times we see situations where the curb ramp's location, if it's included in the scope of the project, could actually be shifted a little bit further up station or down station, and then that full 5 foot desired or standard landing width could be achieved. So that's where I'm trying to nudge our transportation design industry to think outside the box. Don't just go with something because the standard plans says to do it and apply it blindly. But we actually want sound engineering judgment to be used and thinking outside the box when we're providing these elements in the pedestrian environment. The other point I want to raise is the sloped portion of the ramp in both instances it shows ramp 1 to 12. That doesn't mean that we expect all of our curb ramps to be 1 to 12. We actually want to provide the least slope that's practicable in that condition or situation. So yeah, you want to increase the level of safety and accessibility by reducing your surface slopes as much as possible. And then finally, I want to draw your attention to the ramp width, which in both cases is dimensioned as 4'0" minimum. I want to emphasize minimum. And the reason I want to highlight that point is on the next screen, we want a better engineered solution. So the next screen is going to show you that the FDM instructions in this imperative statement says to provide ramps that are the same width as the sidewalk. So if you have a 5 foot sidewalk, the ramp should be 5 feet wide. If you have a 6 foot sidewalk, then you have a 6 foot ramp. And the reason for that is just like the phrase, a chain is only as strong as its weakest link, that I would suggest to you that a pedestrian facility is only as accessible as its least accessible component. So if you have a nice wide sidewalk, but it funnels down to a 4 foot minimum ramp at every street crossing, then you're restricting the flow of pedestrian traffic at those pinch points, if you will. All right, for surface, when there are surface features within the walking surface itself, ideally you want to have those relocated, but a lot of times that's not included in the scope. So when surface features must exist within the surface slope of within the walking surface itself, then the top of those surface features, be they utility boxes or other features, they need to comply with the walking surface requirements of the ADA. They need to be firm, stable, slip resistant, and they must be in the same plane, if you will, as the surrounding walking surface. So there are no changes in level or openings that are greater than 1/2 inch. In the picture on the screen, you can see that a contractor, I think, was trying to do his due diligence and provide a detectable warning surface that reconciled the fact that there were utility boxes located right at back of curb. And so he broke the detectable warning surface. It's not continuous across the width of the ramp. Ideally, though, a much better compliant solution would have been to scoot the detectable warning surface back away from the back of curb. It must be within 5 feet, and I'll show you that dimension in a minute. But by moving the detectable warning surface back away from the back of curb, you'd be able to miss the surface feature there, the utility boxes, and you'd have the full warning message being displayed across the full width of the ramp. Now, this picture has been in this training PowerPoint presentation for several years now, and I like it, so I'm keeping it in there, not updating it with a new picture, because it clearly, in my mind, emphasizes the point that we don't want just nominal compliance, because this is a nominally compliant solution. But is it substantively safe and accessible as we can make it? I don't think so. I think that with a little bit of shifting of the curb lines, we could provide that a curb line alignment that is in alignment with the crossing direction. And we can provide that clear and effective communication by providing these non-visual, physically detectable elements that can communicate the direction of the crossing to those who might need that extra information. Because the information is available to someone who does not have a sight impairment. We have a responsibility under the ADA to provide tactile and detectable information along the walking surface to provide information equally so as someone would have available if they don't have a sight impairment. So the language in the FDM says should, but I would encourage everyone to kind of think must when you read that. Okay, I think in my opinion, the paragraph in the upper left corner of your screen, the first half of that sentence kind of overcomplicates the message that we're trying to convey, but the second part of that sentence is pretty clear. We want to provide curb ramps, excuse me, at both ends of each crossing. The reason for that is that if we invite a pedestrian into the roadway environment where there are vehicles, if we invite them in on one end of the crossing, then we need to give them a way to get out of the vehicle environment on the other end. So in other words, you can't have a curb ramp on one curbed end of the crossing and then lead them across the roadway to a corner that is missing the curb ramp, because they'll be stuck in the vehicular way. So we need to give our pedestrians a way in and a way out, and that speaks specifically to both safety and accessibility. Notice in the picture at the bottom, the existing alignment of the curbs for the curb ramp are not in line with the crossing. They are pointing out to the center of the intersection. But with a little bit of forethought and consideration of this criteria in advance, a more substantively safe and accessible solution would have been to kind of tweak the alignment of those curb lines to align with the crossing. In the paragraph on the lower right, it says crossings are required to meet the same grade and cross slope requirements as sidewalks. So our roadway crossings must hold to a 2% max cross slope, and they generally follow the profile grade of the parallel roadway next to them. There's only one exception to this, and we'll talk about that in a future slide. But where that can't be met, that design criteria can't be met, and I'm speaking the nominal criteria, if it can't be met, then a design variation must be processed at the district level. Okay, so hopefully by now you would see from the two details that are shown on the screen, you'd probably figure out that the preferred detail, in my opinion, would be on the right, where you have individual curb ramps that are providing the curb returns and alignment information for each crossing direction on that corner. Now, obviously, this is not achievable a lot of times because of restricted right-of-way, where you end up with a situation like option A or option B on the left side. You'd want to try to avoid option A, because once you step into that depressed corner, a person with a visual disability kind of loses contact with anything tactile that would direct them to the appropriate direction of the crossing. Don't get me wrong, option A is nominally compliant, but is it the best substantively safe and accessible solution we could provide? Maybe not. Option B, I think, is preferred of those two options, just as long as you make sure that the detectable warning surface remains within 5 feet of the interface between the walking surface and the roadway at that point. Okay, for those of you who are CAD enthusiasts or technicians, there's some links here these are hot links in the PDF download from the control panel for this GoTo meeting. But these are some links that were provided by my friend and colleague Vern Danforth, the head of the CAD office here in Tallahassee. So if you need some additional training or information, or just want to see some best practices and tips and tricks, then I would encourage you to access some of these resources. Okay, for driveways, very similar to what I kind of alluded to earlier about sidewalks. If the sidewalk is not included in the project scope for improvement, then existing sidewalks that are 4 feet or greater can remain. Similarly, for 3R projects, if the driveway is not included for improvement in the scope, but it's known not to be in compliance with the standard plans, then reconstruction is not required. But if it can be improved with zero or negligible impact to scope, schedule, and budget, I would encourage our district to include that in the scope from the beginning. But we understand that that's not always possible, and these are the conditions that must be met at that time. But I do want you to direct your attention to some language that's in FDM 114, where it mentions identifying elements that can be improved during the course of a 3R project, but that's up to the district to decide that during project development. Okay, crosswalks. Obviously, these are where pedestrians should be expected in the vehicular environment, right? They're crossing from one PED facility to the other PED facility on the other side of the street. Where ADA comes in is not only the cross slope must be 2% max, but you've also got an alignment issue that needs to be considered. The picture on the screen shows during construction, this is a temporary alignment, I believe, but there are two kinks in the cross slope, or excuse me, there are two kinks in the alignment of the crossing. And there's nothing there that's physically detectable or non-visual to clearly and effectively communicate the change in direction to someone with a visual disability. So ideally, we'd like to see crossings with a tangent alignment. And if there must be a change, like for example, in the center refuge island or the median or something, at a hardened center line or bullnose, then we would definitely encourage the addition of some sort of tactile or non-visual, physically detectable element to communicate that change in alignment. And I want to mention here, because I get the question a lot, but accessible parking, what we used to call handicap parking, but we steer clear of that word because it's just not as an appropriate term anymore. I would encourage you, if you need accessible parking details, to refer to Index 711001 for that information. Okay, this is a big one. This has been a challenge not only on the state highway system, but also on our local roadway network with cities and counties. It's the alignment, it's the appropriate and correct alignment of the PED push button. This is a big one, so please, if you've kind of tuned out, pay attention to this one. The appropriate alignment, and this is from the MUTCD, so it's a national standard that DOT has obviously adopted. But the PED button face and its associated sign must be placed on the pole so that they're parallel to the direction of crossing. So in the picture, it shows the near pole with the button, and the button is actually pointing down the direction of the crossing, and that's the wrong location. That's indicated in the lower left diagram with the red X through it. The correct and appropriate location is parallel to the direction of crossing. And the reason for that national standard from the MUTCD is because the button placement provides that non-visual, physically detectable information that clearly and effectively communicates the direction of the crossing for someone who has a visual disability. Okay, so, and it's an MUTC standard because it's meant to be consistent across the country. So someone traveling to Florida from any other state in the union will know how to function in and operate within the pedestrian environment for our roadway network. But if we do it on our whim, or if we have button placement that's inconsistent, then we're not providing that effective communication that the ADA requires. Okay, this detectable warning configuration in the picture is nominally compliant with the criteria, but is it substantively the best solution that could have been provided here? And I would suggest to you that because of the wraparound nature of that environment, or of that detectable warning surface, it's actually communicating that in that corner, that wrapped corner, is an appropriate crossing direction, when in fact it's not. So what could be done better there? It could be maybe a raised concrete curb, or little traffic separator kind of thing. I'm not sure. You definitely have to reconcile all of the appropriate design criteria for roadside safety and all those issues. But I would suggest to you that just think outside the box. Sometimes a solution like this might be the only one that's possible or feasible. But where we can do better, I would urge our design community to give it some additional thought. Now, the detectable warning surface, as I hope you all know, is a distinctive surface pattern of truncated domes that communicates where the crossing occurs, where the pedestrian environment is about to interface with a vehicular way. It's not meant to be an alignment indicator, which is why we need additional non-visual, physically detectable elements at these locations. Now, the detectable warning surface must cover the full width of the crossing surface, of the walking surface, and be 2 feet deep in the direction of travel. And they're required at the areas that you would think of logically, anywhere that the pedestrian facility is going to cross a roadway facility. But there's some other little points and locations that are summarized by bullet points on this slide. For example, in pedestrian refuge islands where there's changes in elevation or changes in horizontal alignment, if you have a 2-stage crossing or a change in surface texture, all those locations would require a detectable warning surface. If you have a pedestrian at-grade railroad crossing, then it needs to be protected by a warning surface. Commercial driveways with a stop sign, yield sign, or traffic signal, that's a common question that I receive. That commercial is the word commercial is in bold there, and there's a reason for that. I'm going to address that on the next slide. The second bullet from the bottom there says boarding and alighting areas that are connected to the roadway with an at-grade connection, that would require a detectable warning surface. But in the picture you have a bus stop there behind a curbed connection with the roadway. Well, that curbing actually functions as a detectable warning surface for an individual with visual disabilities. They can detect that sudden change in elevation and know that they're not intended to cross there. But if it's an at-grade connection, then the detectable warning surface is necessary so that we're effectively communicating that it's essentially the end of the PED facility and the beginning of a roadway. Okay, the first sentence here says detectable warning should not be placed where sidewalk intersects urban flared driveways. That's a reference to Index 522003. So you want to follow the guidance in that standard plans there. But let me say here, this is an important point to make, that the applying of standard plans and FDM criteria does not alleviate an engineer from their ethical and professional responsibility to provide a safe and accessible design. So just because it's nominally compliant does not mean that it's relieving the engineer from their needed application of sound and effective engineering judgment. So we can address that more during Q&A if anyone has any questions about that. Okay, and Spec 527 is the construction specification for detectable warning surfaces. All right, real quickly, we're going to show how the construction environment is to be addressed in the design plans. And that may sound like a new direction for most, and it's actually not. It's been our approach for the last 3 or 4 years. But I understand that idea of handling temporary traffic control in the design plans versus letting the contractor handle pedestrian accessibility is kind of like turning the Titanic. So just bear with me, buckle up a little bit, and we'll talk about that here. Temporary traffic control plans are required for work zones that are adjacent to highways, and that's in Florida state law as well as in federal regulations. And as you know, there are commonly accepted or commonly encountered situations that are covered by details in the MUTCD. The DOT Standard Plans 102 series has taken those common situations from the MUTCD and put what I call the Florida spin on how we want to see those implemented on the state highway system here in Florida. But the last sentence is very important. It says most work zones will require further development of these typical applications to address project-specific conditions. So think of that back to what I've been talking about with the borrowing the idea of nominal compliance and substantive compliance from the HSM. The direct application of a standard plans to every situation is not actually going to be substantively compliant at all, because it says here most work zones. I would suggest to you that maybe more than most, nearly all work zones are going to require some degree of additional development of those standard plan details, because you have to address project-specific condition. And I received some comments and pushbacks the last time I delivered this on this particular point. Please don't shoot the messenger. It's written into the FDM, and you're going to see in a minute it's actually in the standard specifications as well. So we want our engineers to engineer the solution and not just cookie cutter apply standard plans details. ADA requirements are in full force and effect during temporary traffic control. And we are required by this language in the FDM to provide provisions for pedestrians at the same level of accessibility as the existing facility. Now, a distinction to that is if we're building a brand new sidewalk in a place where sidewalks did not otherwise already exist, then pedestrian accommodations are not necessarily required. And I put that stipulation, not necessarily required, on it because, again, using engineering judgment, if there is a obvious pedestrian presence because of goat trails or other indications within the project limits, then that's something that at least needs to be considered for accommodations, because if there's indication that pedestrians are using that roadway shoulder, if you will, but there's no designated pedestrian sidewalk there, we still have an obligation to provide for that mode of travel, even though there wasn't an existing facility. And the picture in the picture on the screen, I've tried to indicate again that a little foresight to the configuration of the curb returns there, and we could have a much more substantively compliant solution there for that curb ramp that aligns with the crossing direction. Okay, PED LCDs, real quick. That's the only temporary traffic control device that can be used for pedestrian longitudinal channelization. And they have to be used to close existing facilities. They have to be used to provide safety for drop-off hazards adjacent to the walking surface. They can also be used to provide separation of the active work zone from the walking facility. And they have to be used on both sides of temporary pedestrian ways. And the reason for that is, again, to provide that non-visual, physically detectable element so that a person with a visual disability can navigate that temporary pedestrian way. If you want additional training on how to handle what we previously called MOT, but we now refer to it as temporary traffic control, I would urge you to search the Central Office of Construction website for that MOT training. Okay, during construction, What we've been talking about is from the FDM, that's speaking specifically to designers. But now we're going to go to look at some language in the spec book, which speaks directly to contractors. And the highlighted portions there state that the contractors provide accommodations in the temporary traffic control plans or as directed by the engineer. So there it states the obvious of what I said a little earlier, that temporary traffic control plans are the responsibility of the design engineer. They're to be a component within the contract plan set. And they must provide a safe and accessible path of travel that is compliant with the ADA. The walking surface must remain, and this is the contractor's responsibility, firm, stable, and slip-resistant, be free of any obstructions or hazards. Temporary pedestrian way must be provided when there's going to be a closure to an existing PED facility for 60 minutes or greater. And it must be ADA compliant. So again, if you have any questions about this, if we can hit them during the Q&A time, we'll do that. I don't know that we're going to have as much time as I'd hoped. 102.660 covers its standard plans. Maintenance considerations, we're going to go through this very fast. We're going to hit the high points. Cracking in the walking surface, that could be a problem for accessibility. Changes in vertical alignment or changes in level, that could be a problem if they're greater than 1/4 of an inch. That's the maximum allowable change in level. Abandoned anchor bolts in the walking surface, that's going to be a problem. The figure on the screen shows how a change in level can be modified to become compliant. That's usually, for example, done on a sidewalk where the adjacent slabs have lost that alignment. They can be ground down as long as they comply with the figure details here. Okay, I mentioned earlier that there were two different vertical clearance requirements. The first one we spoke about was 7 feet to fixed objects. Well, this one is 8.5 feet to vegetation. So 7 feet for fixed objects and 8.5 to vegetation. For lessons learned, sidewalk brick pavers can be used. They're not prohibited to be used on state projects, but let me say that the construction techniques and approach has to be pretty sharp in order for that walking surface to remain compliant over time. And you can use your imagination to see what I might be alluding to there. But if there becomes any changes in level or open gaps between the adjacent bricks, then that's going to become inaccessible as far as the ADA is concerned. On your screen, you see two pictures of some interesting, let's call it interesting application of detectable warning surfaces. These are not nominally compliant or substantively compliant installations for your detectable warning. Look out for obstructions that are blocking your public service that's being provided by a sidewalk. Make sure that the interface between the walking surface of the pedestrian facility and the roadway remains fully accessible. The picture on the left shows a temporary pedestrian way that has been installed, and it's effectively blocked and becoming inaccessible because of where the contractor placed the temporary road sign post. The picture on the right is showing one of the pitfalls, if you will, of detectable brick pavers. Picture on the right shows a best practice on the separate ramp. In this case, we're talking a blended transition and not a sloped surface ramp per se, but it is providing for the different directions of crossing. Be careful of your shrubbery and vegetation overgrowing into the pedestrian environment. Again, those vertical clearance requirement, 7 feet for fixed objects and 8.5 feet for vegetation, apply over the full width of the walking surface. Picture on the left is indicating again how a little forethought and tweaking to the curb lines could increase the level of safety and accessibility from a substantive point of view. On the right, the contractor, I think here is trying to utilize asphalt millings to provide a walking surface. And we have seen applications where that's been done successfully, but I'm not sure that that's the case in this picture, because it ends up providing what looks like stepping stones towards the crossing of the main line on the other side there. So I think that needs to have sufficient details in the plans so that the contractor can provide a compliant solution there. Changes in the level we've talked about curb lines, drop-off protection, that's covered in the FDM Chapter 222 and in the Green Book. Look out for your operational safety issues. In the case on the left, you can see that that vehicles are overrunning that detectable warning surface. Watch out for your horizontal unobstructed clear widths. That would be measured between the railings in the case of the boardwalk there over that drainage canal. And single finger buttons are no longer considered accessible. So you'd have to have the modern standard for that. Picture on the left is a best practice for having separate connections to your roadway crossings. On the right is an example of where you have a temporary closure due to utility work. But if it's going to last 60 minutes or longer, then there must be a temporary pedestrian way or detour provided. Keep in mind that your detectable warning surface must be and remain within 5 feet of the interface between the walking surface and the roadway. And the picture on the right is showing an overuse of detectable warning surfaces because at least 2 of the 3 installations that you see there aren't necessary. Keep your walking surface free of water ponding. That could be a barrier to accessibility as well.